Hello and welcome to the next tutorial. Today we are going to look into the interface types and how the communication to the HMI works. So for that we have a data type sheet which contains all of the data types that are required for the communication to the HMI. Basically how it works, let's just go to the global variable list. You can see that we have a HMI group which contains the interface and HMI variable, and both are a interface struct data type. So let's take a look at the interface struct data type. First of all, we have a variable which is called enable HMI interface. Basically, you can use that if you want to cut off the communication to the HMI so that you can work inside the PLC project only without getting values from the HMI, so that you can work with the HMI structure in here. Let me show you in the HMI project where you can find it here in the background. Here we have the enable HMI event painter, which is writing a 1, so 1 equals true to the HMI interface variable on every repaint. So basically that means it is always enabled, but if you want to disable it, you can write it to 0 here. Then we have the command structure, which if we scroll up is placed here. And here we have two sections, let's say. One section is not resetted automatically, and the other section is resetted automatically in HMI out POU. What that means is that, for example, if you set a variable to true in the HMI or to 1, and it is going down to the PLC, and the PLC receives that variable, and the variable is resetted from the PLC when it is inside that section here. So the PLC sets that variable to false, and that's it. So for example, if we have a jog command and the user is pressing the jog button, and you don't want to set the jog command to 0 every time the PLC receives the true or the 1 command. So the jog functionality should work all the time. But if we press, let's say, power on in the HMI, we set it to 1, and let me show you what I mean. If we go to the power on button here, and you can see on mouse up we are writing the variable to 1, then it comes to the PLC. The PLC receives the command and resets it in the PLC project, and this is done in the HMI directory here and in the HMI out. So in the HMI in we get the command here. You can see if the HMI communication is enabled, we listen to that command, and if we get that command, we reset it immediately. So in that way we get a good handshake between the PLC and the HMI, and inside the PLC project we go ahead and work only with the interface variable. So and here in the reset, HMI out reset, we can see that the command variable in the interface structure is also reset after something was done with that variable. So every variable from interface command memset start to memset end will be set to 0 after it went through the POUs or the tasks. So you can see HMI in is placed on top, and it receives the variable. Then we go through, and every POU will do something with that. And in the HMI out, it is resetted again. So in that way, we have a reset of the interface variable and a reset of the HMI variable. And then we have a status, which you can use to send the status of the machine, for example, to the HMI, and also status for EtherCAT or errors, warnings. Of course, you feel free to modify all that and replace some variables or things you don't need. You You can also delete stuff. And process is for process data like the machine speed and the back length, for example, and stuff like that. So yeah, here you can see the master velocity or cam table ID. So this is basically for variables that are important for the process, but in most of the cases, yeah, you can also replace it just by using command and set variables, and it's up to you how you set up the project, if you want to keep that or if you want to delete it. Just an example how you can do it. And here you can see the set structure, which is linked to the setting structure, which is important for machine settings. And let's take a look at that as well. Here you can see the settings struct, which has several settings for a touch probe, for example, cam switch, drive arrow selection when you want to read out the arrow from the drive, which drive you want to read out the arrow from, and yeah, an act struct, which is linked to the actual struct, which contains actual values. So yeah, also for EtherCAT variables, drive arrows, trend values, drive number of drive arrows, and so on. So yeah, you can extend these types, of course. And just to show you how it works, I will insert that HMI variable here, and it will recognize that it's already in the global variable list in the HMI group. And then you can say dot, and you can see the variables and can see the actual values from the EtherCAT slaves in operational, for example. And this is how it is built up.